The presentation we're going to present to you is about robot simulation. First of all, welcome. We're Team 930. Rapid React was our 21st year. We were the Einstein finalists in 2019 and achieved the Hexfecta of awards.
Okay. I'm Harrison. I've been FRC 930 for a year now.
I'm Ed. I've been on FRC for about 3 to 4 years now. And we got our mentor over here, Steve. Do you want to?
Yeah, I've been on the team as a mentor for 2 or 3 years, and then before that I had a son that was on 4 years before that. So.
Okay. Today we'll be going over what is simulation and the basis of it.
From there we'll move on to how it's benefited our team and how it will probably benefit yours if you choose to use it. Then we'll show you a few things that simulation can't do, unfortunately.
Then we'll go over the key parts of robot simulation and how you can use them.
We'll then start our demo of debugging and with simulation.
And then we'll move on to the rest of our demo. So you might be asking yourself, what is robot simulation? Well, robot simulation is an application provided by FIRST to simulate various parts of our robot digitally instead of using a physical robot. If you're asking where can I get robot simulation, it is provided with the dev tools that are provided by FIRST and WPI. Simulation can also show us values of our digital robot or fake robot. And you can also use the FMS, which is down there, bottom left corner, to adjust field settings. You can also simulate inputs from like sensors using DOs and other things.
So now we'll move on to team benefits. Does anybody have any ideas on how simulation could benefit your team?
A lot of times our mechanical and electrical team is currently in control of the robot and is using it. We can still test our code while they're doing their thing.
Anybody else?
If there are features that aren't fully complete yet on the mechanical side, you can test them.
Yeah, so both of those pretty much explain my first point. Simulation allows you to test without your robot. And this means we can test early in the build season before the robot's ever completed, which saves a lot of time during the busy hustle of later build season. It also means that we can simulate while the robot's being used for other things like electrical or mechanical, having to use it, or other testing or drive practice. Also, we don't have to worry about damaging the robot while using simulation. One time in a competition, we ran into a wall, and we probably could have avoided this by using simulation beforehand to find some of those small issues and fix them. Also with simulation, there's a much smaller setup time. Generally, when you're testing with your actual robot, you might have to get your robot into a place where you can test it. Like if you have to test your shooter, you have to find an open space with lots of room, set up a hub maybe, or some target, and then you can finally test. With simulation, you can fix a lot of things much easier. It also really does help when you're trying to identify if an issue is mechanical or programming. Because if you run through your simulation with your code, you can almost guarantee that it's a mechanical issue if everything's working fine in simulation. And obviously all these points, and the main point is that all this saves time. It allows you to be a lot more efficient with what you do during your build season, and lets you get a lot more done. But now we'll move on to some things that simulation can't do. Which, first of all, you should always keep in mind that after using simulation, you should still test that feature that you added with the actual robot, because there's a lot of points where simulation can be imperfect. One case of this is motors. You can see here we were using CAN Max and motors, some CAN Max and some other motors just aren't supported in simulation. So we have to get around that by using robot.isreal. And this can lead to more issues, because what happens here is this is the code, or well, this is a better example. This is the code that you're actually using, while this is what you would be using during competitions and such. But that's not what you're simulating. You're simulating this. So if there's an error here, you don't catch it with simulation. Also, simulation unfortunately can't simulate Limelight and other cameras, because those take inputs from the real world. And you can also use DOs to simulate time of flight sensors and the such. I don't have a picture of that up here. Yeah.
Okay, now we're moving into the key parts of robot simulation. First off, we have the robot state, and this is very generic. It just shows you the state that your robot's in, that you're running in simulation. So let's say I want to run an autonomous path, and I want to see how that works in simulation. There's the autonomous robot state. If you have a controller and you want to test some inputs, you can use teleop. And then test is along the same lines of teleop, where you push in inputs and then you get an output. Next we have our timing, and this is where we can run, pause, and stop our simulation. So the run is the default when simulation starts. Your simulation will automatically run. Pause is if you want to stop simulation and see into the code more. And then step is along the same lines of pause. Basically, as long as you hold it, it will move on through the code, and then when you let go, it'll stop. Over here, we have system joysticks and our joysticks tab. This is where you'll see your inputs, like the Xbox controller right here, and you'll want to drag those over to any of these unassigned areas. Most of the time, it'll be the first area, and that's how you can actually input into simulation and drive around. We'll see. There we go. Sorry about that. Next we have our FMS, which is the field management system. Right here you can see the FMS attached and the driver station attached. Basically, you can simulate if you're actually running a competition through the FMS. And here's many other settings you can use. The line station, you can choose between the 6, the red 1, 2, and 3, and the blue 1, 2, and 3, if that applies to your code at all. Over here we have the other devices. This is where you'll see most of your motors, and this is where where everything is inputted that doesn't fall into any of the other categories from the key parts. That's fun. Next we got our network tables. Our network tables are basically kind of how your robot communicates with other programs. For example, the driver station and the field management system will communicate with each other through the network tables. And that's how the actual network tables are used. This is how we simulate those network tables. Now we simulate the FMS, and the other tabs aren't on here, but like the driver station and our shuffleboard. First off, we have in our network table our smart dashboard. And this is where we get values from our smart dashboard. On here, we have a digital field that we use. You'll see this later in our demo, but basically we have an image of a field and we have a little arrow or robot moving around it to test autonomous paths. You can use smartdashboard.put to push things up to here and actually use them on your simulation. Next, we have our live window, and you'll see here a bunch of our subsystems. And then this is where you'll see a lot of your test modes and a bunch of other information from your robot. And then next is our FMS information, and then this is where you'll see the field information you're working with, like if you're Red Alliance, the game-specific messages, and a bunch of other things.
So now we will, So now we'll be getting into our demo. We use debugging, or we use breakpoints a lot with simulation to make it a lot easier to debug. Because if certain parts of your code aren't working, you can go through and change values with your DO, and you can find what part's breaking in your code and logic.
Go ahead.
So, first of all, this is how you get into simulation. You'll have to press the W in the top right of your WPI lib to open the command bar. From there, you probably won't have it at the top of yours, so you can just type in sim, and then it should be one of the first three options. It'll build, and then it will give us a little selection. You can simulate your gyro station, but generally we'll just be using the GUI.
Oh, you still have to do the breakpoints.
Yeah, so you have to make sure that you go into, or wait. So first, if you go into this hardware tab, you can get a lot more of your,
And that's where you'll find a lot of your inputs that you'll be inputting, like the DOs, which are our sensors.
so we want to turn these all to low first so that they aren't detecting anything. We aren't using the first four right now, but we would still want to turn those to low so that they aren't affecting anything. And then these two DOs, 5 and 6, are the ones that we'll be using. So the motors that would be affected by this would be 13 and 14, which you can find in your other devices tab here. And you can open those up, and it'll give you a few, it'll give you some information about the current state of the motor. So here we can go to our code and place a breakpoint like that. And from there we can turn our simulation onto teleoperated so that our code is running. And you can see our breakpoint will trigger. So we can go through this right now, and it'll of course say all of this is false for right now, because these DOs are set to false and low. So we can go through and make sure our logic is working correctly. It goes to the else, it sets that motor. Here it'll also see that both of these are false, so it'll set this intake motor here, and then we can go back to the start, and we can change these values, and as you can see, once we go through it again, it will now say these are true. We can make sure our logic's working.
Show where it says true.
Oh yeah, so it says true. You can look right here, for what it's telling you that the current output is, or input is. And then you can make sure all your logic is working correctly using simulation and breakpoints.
Show them on the simulator the motors are moving.
Oh yeah. So then we can remove the breakpoint.
I will continue the rest of this demo. So, next we're gonna wanna remove the breakpoint, just so now that we're testing the rest of this, where our code isn't gonna get stuck in here. So now that we got the breakpoint removed, we can just hit continue, and our code will run like normal. And now we can go back to simulation, and always remember to turn this to tally up. Sometimes you'll forget to turn it to tally up and it'll be disabled and you'll be wondering what's going on. So yeah, over here, we have our open tabs. These are basically a part of our indexer system on a robot. If you don't know an indexer system, it's basically, we have two sensors and then it's kind of loading them into the chamber for a robot. And so these are sensors that are telling a robot what to load in. So if we change these to false, as you can see over here, the values are changing. So you know those are working. Is everyone following along? Good?
She has a question?
You have a question?
Yeah, I'm a little confused, like, what does the breakpoint do for you?
The breakpoint basically pauses your code, and it will kind of, it's hard to explain. It pauses your code so you can look more in depth. So if you're having a problem with your shooter, you could put a breakpoint somewhere in there and then just follow along and see when things are updating, and then get an output from there.
Yeah, you mark a part in the code where you expect the code to be run, and then when the program gets to that point, it'll interrupt it. You have an opportunity to look, examine the variables and things like that, and even adjust variables, and then continue on. It's just a way to stop the program from running when it hits that part of the code.
If you're more curious about that, I think at 3 p.m. we'll have a debugging workshop that will go into more in depth about breakpoints and other debugging tools.
Okay, and then moving on, let's get rid of the DO because we're not going to be working with that anymore. And then let's go into network tables. So for us, we use network tables for a lot of this. One of the things I'll show you is our FMS info and all this. As you can see, it says the red alliance is true, and down here a little more, it will show our station number. As you can see, it's red alliance and station 1, same as the one down here. Now if we change this to blue 2, you can see now it's actually changed in our network table to our no longer the red alliance and also station number 2. Now I'm going to use our network tables to use something we've already made, which is a field. Now, most of our computers actually have a field image on here right now. This one hasn't been updated with the field image, but you can see what's going on basically through this. We also are going to have to pull up, if I can get to it, our Auton path selector. And then this is from our shuffleboard. And then this is where we can choose what Auton path we're using. For this, we're going to use our 5-ball auto, and then we're going to want to disable the robot before we do anything. And then to show that simulation, not simulation works, autonomous works in here, we run that, and as you can see, our robot's moving. And let's say I want to pause and look at some values. I can pause there, or I want to look at how it's moving for a specific period of time. And I can use the step, I can hold it, and it'll run through that, and then I can let go and it'll pause. There's a demo. As a recap, let's go to the front. We went over what simulation is with a brief overview.
We also went over how it's benefited our team and hopefully will yours. We also went over what it can't do, like those motors, limelight, and other things.
We also went over the key parts and how to use them and how you can use them for your team.
Then we went over debugging with simulation, which will be more in depth later today.
And then we ended with our demo, showing you how these work and how you can use them for your team. Thank you. Does anyone have any questions?
What motors can you not simulate? You said you can't simulate the spark that can spark.
Yeah.
Are there any other ones that you know of that you can't simulate?
We have mostly been using Talon, as well as long as I've been